My report is based on the data from area of the eastern Lithuanian barrow culture, which is a region with a great number of barrow cemeteries ranging from one to several to tens or hundreds of mounds. But the number of known settlements is very low, and little is known not only how these settlements looked like during their existence, but even how they currently look like in archaeological context. The main elements of Lithuanian Iron Age settlements are a dark cultural layer, occupational layer, amorphous subsurface features such as pits and artifacts. Up until very recently, the cultural layer, which is usually non-stratified, hosting a range of mixed artifacts from different periods, was considered as an indication of the length, continuity, and intensity of the site habitation. And an effort was usually made to excavate where the cultural layer was thickest, whilst the zones without cultural layer were considered to be destroyed or uninhabited and consequently not excavated. This in turn resulted in smaller excavated area, rarely exceeded 500 square meters, scattered in separate small units rather than a single unbroken area. And this is one of the reasons why buildings are in general almost never found in the Iron Age settlement sites in Lithuania. Post holes have been abundantly discovered, but they do not show any clear arrangement that would indicate distinct outlines of buildings. The collecting of finds during excavation was guided by museum perspective, and almost no laboratory analysis, including macrobotany, chemistry, were conducted, and no samples were selected for it. Under these circumstances, data accumulated so far can only be used in a very limited manner for settlement life history in its original sense, and we must look for secondary evidence and to integrate different methods and data in order to take a full advantage of archaeological information contained within archaeological settlements. I am going to present the primary results from the interdisciplinary research at the settlement site, which was recently discovered nearby one of the largest barrow cemetery in eastern Lithuania. The presentation of the result is not an end in itself. I made an attempt to verify an assumption there were nearby archaeological objects, in this case a settlement and a burial place, which are often considered as a common archaeological legacy of one community, survived the same or a similar life history. In this context, the component of life history might be considered as a synonym of object chronology. However, a component of biography in a way emphasizes a change in culture, practice, and ideas rather than sequence of events. As can be seen here, the study area is covered by dense vegetation, and the forested environment limited the range of potential methods like systemic magnetometry or surface survey, and decision was made to employ the combination of magnetic susceptibility and phosphate analysis. By the way, these methods were used for the first time in Lithuanian archaeological prospection. Therefore, not least important were to assess how do they work, if they correlate or complement each other. So here we have some information on site geomorphology. The ecological complex is situated on the first fluvio-glacial terrace of the Šventoji River, rising 8 to 13 meters above the present water level. And as you can see here, Barrow Cemetery, as I mentioned, is one of the largest unit of barrows. It includes two neighboring barrow cemeteries of over 300 mounds, which are scattered in an area of around 25 hectares and are dated to the 6th, 11th century. During the period of 2000-2007, the area of over than 1,500 square meters were researched in the Barrow Cemetery. The ecological excavation were performed in almost continuous zone, which provided data on the spatial and chronological evolution of burial rites in the researched part of the cemetery. And it has been established that barrows dating to the 6th to 9th century AD were located on the eastern slope, and we contained human cremations with grave goods. Barrows on the western slope of this hill in the central part were dated to the 10th, 11th century AD and contained no human burials. One of the barrows hosted a burial of a horse, and the rest were either empty, which is also sometimes assumed as a symbol of horse burial, or contain attributes relevant to horses and riding, as we can see in the bottom. Several years ago, on the same terrace, a settlement was discovered nearby the cemetery by digging test pits. What was of special interest? No obvious natural barriers between the living and the dead were noticed. Generally, a stream or differences in altitudes are assigned to this role, especially considering the sites to be simultaneous. Therefore, the determination of these sites' chronology and extent of a settlement site became an important task for us. Here we have a strategy of horizontal sampling, and manual augering across the site was chosen, and geoarchaeological research was carried out for over 800 bulk samples. Soil samples were collected in every 25 meters in lines, with a distance of 5 or 10 meters in between the bores. In total, about more than 250 bores were made, and approximately 4 hectares were surveyed. The samples were taken at different depths in soil, exposed soil sections, from topsoil, from humus soil called cultural layer, and subsoil. Sometimes 3A horizons were apparent, as we have on the right, but usually only a few centimeters thick darker layer could be distinguished in the lower part of the topsoil. In other cases, the presence of archaeological layer could only be assumed based on the topsoil thickness exceeding 20-25 centimeters. Of course, data from different contexts cannot be interpolated, and the results should be analyzed for each horizon separately. So for presentation purposes at this workshop, the uppermost horizon were chosen to display, and after some experimentation, the results from topsoil and cultural layer were averaged for horizontal mapping. Shortly about the methods. Especially magnetic susceptibility analysis has been vital on this stage of research, and it was measured in a laboratory condition. Loss of ignition method was used to establish the organic material content, and for phosphate analysis we used spot test as a field method and hydrochloric acid extraction for ignised and unignised samples. And the procedure was almost the same as just Radoslav described. The differences is like only acid selection. And seeking for more detailed information about sampling context, the acidity of soil, content of carbonates and texture were determined also for several samples, but I'm not going into details of these results. They were valid only just for general information. And here we have a vertical results. Distribution of magnetic susceptibility data at different horizons. And red boxes indicate that data from the first two groups, namely topsoil and cultural layer, statistically differed from two others, and their median confidence intervals do not overlap. Such distribution confirms the statement that topsoil generally has a higher magnetic susceptibility than most subsoils due to impact of fire, fermentation effects, or oxidation reduction cycles, when weakly magnetic compounds of iron convert to more strongly magnetic forms. As can be seen on the right, organic matter in the upper levels of soil profile 3 to 4 times exceeded the organic matter content detected at subsoil level, which is logical, having in mind that organics accumulate on the top of soil profile. And here we have the results of 3 methods for determination of phosphorus content. Spot test analysis was used to rapidly assess distribution of plant available phosphorus. It has been observed that more phosphorus was extracted not in the topsoil or occupation layer, but in the subsoil. Such phosphorus distribution might be related to soil formation processes like phosphorus leaching from topsoil. For a more precise determination, we choose, as I mentioned, hydrochloric acid extraction, which, by the way, was selected after 20 methods has been experimentally tested for a series of samples from 5 different sites. The goal of this experimentation was to pick out a cost-effective and reliable method for the determination of soil phosphorus in comparison to total phosphorus as was determined by XRF analysis. Unfortunately, for this site, the applicability of this method appeared to be rather limited. It did not show differences between the horizons and did not match the distribution of total phosphorus as detected by XRF analysis. Therefore, a further strategy was used to analyze the distribution of organic phosphorus, and the results depicted in the below diagram demonstrate a regular decrease in organic phosphorus in relation to depth, which correlates with decrease in the quantity of organic and with total phosphorus. And here we have a horizontal distribution, results for horizontal distribution, distribution of cultural layer, which is marked by black dots. And we see that the densest cultural layer was closer to a river, and the soil profile exposed up to 1,000 centimeters with blackish horizon below the topsoil sometimes reaching 40 centimeters and more. Here we have interpolation of a magnetic susceptibility averaged values from two uppermost horizons overlaid by the point data. As it can be seen, neither the thickness of a cultural layer nor its very presence was the main cause for magnetic susceptibility enhancements. For instance, samples taken where the cultural layer was the thickest, on the left, featured similar or even lower magnetic susceptibility values as some of the samples taken 200 meters away from the river, though no traces of cultural layer were noticed in this area. Much larger magnetic susceptibility enhancements have been recorded at several spots in the central part of the sampled area, located 30-60 meters away from one another, and small trenches were excavated at the spots of these enhancements. Two of them reveal burning-related evidence which proved the efficiency of this method, basically. Several hundred potsherds were found in one of the trenches. Most of them were secondary burnt potsherds, which, to my mind, imply the traces of fire. The other trench revealed a pit containing fragments of burnt clay daub. Two other trenches revealed shallow pit-shaped features of undetermined function, and no artifacts were found within them. If we compare the spatial distribution of magnetic susceptibility and organic phosphorus, both surveys show only slight correlation. Phosphorus enrichment, as we can see it in the southern part, has not been tested ecologically yet, so this is the task for near future. Most likely, these two surveys defined areas of different activity and processes. As we know, anthropogenic addition of phosphorus to the soil are usually derived from organic products like human refuse or animal dung. And here we have the distribution of organic matter content as compared to organic phosphorus. I'm afraid the layout of averaged values of organic matter is distorted by high values from topsoil. But if we take values for cultural layer only, the zone of phosphate increase does not fall outside the area of the organic content enrichment. So how can these results can be useful for interpreting the life history of settlement? As I have already mentioned, it was difficult to establish the border between the dwelling site and the burial site. The growing barrow cemetery could have covered some parts of the habitation site. And the conducted a geoarchaeological survey provided us with useful information. And now we know that magnetic susceptibility values and organic phosphorus content decreased considerably towards barrow cemetery and imply that the settlement did not stretch further south, and it was distanced from the nearest barrows for at least 80-100 meters, maintaining the distance between the dead and the living safe enough. The excavation performed have shown that anomalies depicted on the isoline layouts were not contemporaneous. There is an area of magnetic susceptibility and susceptibility enhancement that was dominated by the pottery typical for the brushed pottery culture and radiometrically as well as typologically dated to the 2nd, 3rd centuries AD. Judging from the stylistically identical pottery, the settlement was short-living and possibly composed of a single farmstead which covered approximately 0.2-0.3 hectares. This episode has not been recorded in the nearby cemetery. Most likely the latter has not been here. Actually, nothing is known about burial rites of brush pottery culture. However, its horizon in the settlement suggests that the deceased might have been buried in the location of barrow cemetery, even if not necessary in mounds. This hypothesis may seem unrealistic on the background of the data collecting during the last 100 years from the entire cultural region. However, it should not be rejected totally, especially considering that previously only barrows were researched in Lithuania, leaving the areas between them not explored. The site has been abandoned for some time after the fire and was re-inhabited in around the 5th or 6th century AD. A major part of artifacts consist of a handmade pottery shed and could be attributed to a 6th, 11th century AD, which is contemporaneous to the material from barrows. Next to potsheds, several animal bones, few fragments of iron slag, fragment of crucible for bronze melting, a few spindles were found at habitation site. We hardly can be attributed to a specific episode of life history of a site because way form remain almost constant. But the very presence of these artifacts imply the variety of household activity. All these artifacts were discovered at the trench excavated where the thickest non-stratified cultural layer was observed. It has been accumulated at the spot of natural depression, whose contours are still slightly noticeable and which was distinguished for its higher organic matter content and organic phosphorus. We took the samples each 2 centimeters down the soil profile, and soil properties appear to be rather uniform. That might imply conditions for sedimentation were stable, or the fact that sedimentation occurred in a single episode, maybe due to activity after the settlement has been abandoned. So, most likely, organic matter and phosphorus anomalies in this part of settlement did not represent habitation area, but rather the traces of post-deposition or the zone of waste accumulation. For a better understanding of the processes behind this stratigraphy, it is necessary to get into the micro level. And as things now stand, the glance shifts to micromorphology, whose potential for the settlement with poor organic preservation has not yet been evaluated. And for summarizing, in a very short period of 1 season, we obtained new data which expanded our knowledge about the lifespan of this particular place in the landscape. A small settlement consisting of 1 or several farmsteads was settled on earlier than the World Cemetery has made its appearance. It is hard to tell where the deceased community members were buried and whether it is reasonable to expect to find their graves in the location of a present cemetery. It is possible that the settlement existed for a shorter time than the expected human lifespan, which was approximately 22 to 27 years, and during that time, no one community member died. After a few hundred years in the re-inhabited settlement, human lived and buried their deceased nearby for at least 300-400 years. Relatively little information available gives the impression of continuity. The possibility that the ecological settlement, such as we recorded, was formed in the post-site period must not be ruled out. Therefore, it becomes important to determine the processes of formation of ecological source. Among the purposes of this investigation was one to develop a toolkit of methods for sites with low visibility. This research has demonstrated that magnetic susceptibility offers a rapid prospection method for settlement interior layout at the unploughed and forested sites by locating highly magnetic spots. Along with phosphate analysis, it appeared to be useful for mapping the extent of an ecological site. From different phosphorus forms analyzed by free method, the extraction after ignition and determination of organic phosphorus appear to be the best suited for ecological purposes at this locality. And as different activities in the past may result in numerous readable outcomes in the present, a combination of different techniques is the desirable approach. However, this should not be an automatic action, but well-considered strategy, inasmuch as both the selection of methods and samples collection may have some influence on the results obtained and thereby on our interpretation. So, thank you for your attention.